Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math, Grade 8, Unit 8, Lesson 7's practice problems. So our first question here is find the lengths of the unlabeled sides. These are right triangles, which means we can use the Pythagorean theorem. Our first triangle has side lengths of 2 and 6 for the legs, and we don't know the length of the hypotenuse. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Not the best looking A ever. A and B are always our legs, so 2 squared plus 6 squared equals c squared. That is our unknown side. 2 squared is 4. 6 squared is 36 equals c squared. 4 plus 36 is 40 equals c squared. How do we get the c by itself? How do we isolate the c? We have to get rid of the squared, so we do the inverse operation, which is square root. If we do it to one side, we have to do it to the other. 40 is not a number with a rational square root, so we get to be lazy here. The square root of 40 is equal to c. So the length of this unknown side is the square root of 40. Our next triangle here, we again know the two legs, A and B. Therefore, 6 squared plus 8 squared has to equal c squared, which is our hypotenuse. 6 squared is 36. 8 squared is 64. Equals c squared. 36 plus 64 is 100. Again, we have to isolate the c, which means we have to do the inverse operation of squaring, which means taking the square root, do it to one side, do it to the other. The square root of 100 is 10. Squared and square root cancel each other, that's why we use the inverse operation. The length of this unknown side is 10. Our next problem shows a couple lines on a grid. Each small grid square is 1 square unit. We have a line here, or a line segment here. The first step to this is to create a right angle triangle. By going straight down from here and left from here, we have created a right angle triangle. What are the side lengths of this right angle triangle? This side is 1, this side is 3. Segment N is the hypotenuse. So 3 and 1 are our A and B. 3 squared plus 1 squared equals c squared. 3 squared is 9. 1 squared is 1 is equal to c squared. 9 plus 1 is 10. Take the square root of each side. 10 is not a number with a rational square root, so our answer will be irrational. So leave it in exact form, which is the square root of 10 is equal to c. So the length of this, I suppose I should call that n, is equal to the square root of 10. P, draw a right triangle again. Side lengths of this one are 3 and 4. Therefore, 3 squared plus 4 squared has to equal p squared. 3 squared is 9. 4 squared is 16, is equal to p squared. 9 plus 16 is 25, is equal to p squared. To isolate the p, we have to take the square root of each side. The square root of 25 is 5. So p is equal to 5. Okay, our next question here. Use the areas of the two identical squares to explain why 5 squared plus 12 squared equals 13 squared without doing any calculations. Well, we know that 5 times 5 here is 5 squared. 12 times 5 this will also be 12 times 5. And then this is 12 squared. That should have been a plus. So we know the area of this, if we decompose all the pieces, is equal to this. Now on our other one, we know that the area of this triangle is 12 times 5 over 2. We know the area of this triangle is 12 times 5 over 2. 2 more. And then we have to add the area of this inner square, which is 13 by 13, which is 13 squared. Now combine some like terms, 12 times 5 and 12 times 5. Without doing that, we have 2 of those. So we know that that is 5 squared plus 2 times 12 times 5, because there are 2 of those, plus 12 squared has to equal 12 times 5 over 2 plus 12 times 5 over 2. Well, if we divide it by 2, and then there are 2 of them, we put it together, that's just 12 times 5. 12 times 5 over 2 here, plus 12 times 5 over 2 here. Put those together, that is just 12 times 5. If we have one 12 times 5 here and another 12 times 5 here, that is 2 12 times 5s, plus the area of that inner square, which was 13 squared. Well, now we have the same thing on each side, so if we subtract that from each side of our equation, those will cancel out and those will cancel out, and we are left with 5 squared plus 12 squared is equal to 13 squared. So without doing any of the calculations, we have proved that 5 squared plus 12 squared has to equal 13 squared. Okay, for our next one, each number is between which two consecutive integers? So the square root of 10, the square root of 9 is 3, and the square root of 16 is 4. So the square root of 10 has to be between 3 and 4, and we show that by 3 is less than the square root of 10, which is less than 4. The square root of 10 is between 3 and 4. Now our next one is 54. Well, the square root of 49 is 7. And so 7 is less than the square root of 54. And the square root of 64 is 8. So the square root of 54 has to be between 7 and 8. Now our next one here, the square root of 18. Well, the square root of 16 is 4. And the square root of 25 is 5. So the square root of 18 has to be between 4 and 5. Square root of 99. Well, the square root of 9 is 81. And the square root of 10 is 100. Last one of these, the square root of 41 has to be between, well, the square root of 36 is 6, and the square root of 49 is 7. So the square root of 41 has to be between 6 and 7. Give an example of a rational number and explain how you know it is rational. This can be any number that can be written as a ratio or a fraction. 2 over 3, that's a rational number. It can be written as a fraction. 4 is a rational number because it could be written as 4 over 1. So there are any number of choices for this. It can just be anything that can be written as a fraction. Give 3 examples of irrational numbers. Well, the square root of 2 cannot be written as a fraction. The square root of 8 cannot be written as a fraction. Any number that is not a square number, the square root of it will be irrational. The square root of 9 is 3, but the square root of 8 and the square root of 10 are not going to be rational. Another example of an irrational number is pi. Write each expression as a single power of 10. When we're multiplying, we add the exponents. 5 plus 0 is 5, so that is equal to 10 to the power of 5. 10 to the power of 9 over 10 to the power of 0. 9 subtract 0 is 9. Quick refresher, anything to the power of 0 is equal to 1. So whatever this is times 1 is itself. Whatever this is divided by 1 is itself. Okay, our last question here. Andre is ordering ribbon to make decorations for a school event. He needs a total of exactly 50.25 meters of blue and green ribbon. Andre needs 50% more blue than green ribbon for the basic design, plus an extra 6.5 meters of blue ribbon for the accents. How much of each color ribbon does Andre need? This is going to be a system of equations problem. First, we have to figure out what our variables are going to be. X and Y will be blue and green ribbon. So he needs a total of exactly 50.25 meters, which means this is going to be measured in meters. If we need exactly 50.25 meters total ribbon, X plus Y has to equal 50.25. That gives us one equation. Now our second equation, Andre needs 50% more blue ribbon than green ribbon for the basic design, plus an extra 6.5 meters of blue ribbon for the accents. So the blue ribbon he needs is equal to 50% more. So 1.5, 1.5 times the amount of green ribbon he had, plus an extra 6.5 meters for the accents. So now we have two equations, and we can substitute one of these into the other. This equation here is already solved for x, so if x is equal to this value, this expression, we can substitute this expression into the x of the other equation. So 1.5y plus 6.5, that takes the place of our x, plus y is equal to 50.25. Combine like terms, 1.5y and another y is 2.5y, plus this 6.5 is equal to 50.25. To get the y by itself, we have to get rid of this, so we subtract 6.5. If we do it to one side, we have to do it to the other. So 2.5y is equal to 43.75. And now to isolate the y, we have to get rid of this 2.5 that is being multiplied. The inverse of multiplication is division. Those will cancel out. If we do it to one side, we have to do it to the other. So y is equal to 43.75 divided by 2.5, which is equal to 17.5, sorry. So if y is equal to 17.5, and we know this equation here is already solved for x, so let's start out by plugging it into that one. X is equal to 1.5. Substitute this value in for y. 17.5 plus 6.5. So x is equal to 17.5 times 1.5, which is equal to 26.25 plus 6.5. Combine those. X is equal to 32.75. So now we have a value for x and y. We can double check it by plugging the values into the other equation. 32.75 plus 17.5 equals 50.25. Yes, that's true, so these values work. How much of each color ribbon does he need? X is blue, so he needs 32.75 meters of blue, and he needs 17.5 meters of green because y is green. Okay, this has been another episode of Mr. Boskin Does Some Math. Thank you very much for tuning in. See you next time.